Yeah, we invented the corporate average data center efficiency, or CADE, 2 years ago as a way of understanding the cost structure of data centers. Oftentimes you have a very siloed approach to the cost structure. You have the IT organization, and they have their costs. You have the facilities people who operate the buildings, and they have their costs. And then you have another group called corporate real estate, and they have their costs. So there's at least 3 different cost centers that you can have costs in. And that's just the minimum, and then you can have more from that. And when we came to the conclusion that IT was becoming less and less economically efficient, is when we gathered together in one place all these costs, and we organized it into the chart that you've seen earlier on the screen. And there are IT costs, and there are facilities costs, and then the other part of the picture is there are CapEx costs, and there are OpEx costs, and the OpEx costs also have CO2 emissions associated with them. And what do I mean by CapEx? CapEx for IT is the buying of IT hardware, typically. That would be servers, storage, routers, the purchase of the actual equipment that does computing. For facilities, it would mean the purchase, the building of a building, the installation of generators, the UPS system, the batteries, and all that stuff. So typically the IT stuff is going to be the computer equipment, and the facility stuff going to be the bricks and mortar kind of things. Now what's interesting is that the facility stuff has a life of 15 years or longer, and the IT stuff typically has a life of 3 to 5 years. So in the life of the facility, there can be 5 to 10 times the IT stuff gets consumed and thrown away, and yet the facility is expected to survive all of that without a whole lot of investment. That's a fundamental mismatch, right, to begin with. So let's now look at the other side, called the energy side, or the OpEx side. On the IT side, the energy part is how efficient is the hardware that they bought. The single biggest thing that's inefficient in the IT equipment are the power supplies. They can be significantly more efficient for spending much more on the power supplies. When we look at the facilities, you get to how can you make the energy efficiency of the facility higher? So if we look at this, we have this Q1, Q2, Q3, and Q4. So in Q1, not only do you have IT buying the CapEx, but how do they utilize the CapEx? So this is where consolidation, virtualization, all come into play. In many cases, we find that the IT equipment is used less than 1% of the time. So increasing the utilization to 10–20% would result in a vastly lower IT hardware cap purchases. When we come to the IT energy efficiency, that gets back to just buying better power supplies. The people who are sharp on these issues don't buy the latest chips. The latest chips tend to be, you don't necessarily need the latest chips to do your workload. So the way to improve IT energy efficiency is to buy hardware that's appropriate to your workload, as opposed to the latest and greatest. And Q3 is where the PUE comes into play, in increasing the PUE. And the problem is that the PUE, the largest part of the PUE, the variability, there's 7 things that will cause the PUE to vary. Just looking at a raw number without understanding the 7 factors, the variables that will make it up, you make some bad decisions. The biggest factor on PUE is the percent of load. The people who determine percent of load are the IT people. Now, if the IT people do a good job on Q1 and Q2, actually the facility people will look worse because the load has dropped. Now, the overall enterprise will be doing better, but facilities will look worse. So just looking at the PUE, it's easiest to understand, but it is not, in my view, it is not the thing to focus on. The thing to focus on is Q1 and Q2, because everybody's buying new hardware all the time. And being able to improve the PUE is relatively difficult, and there's some risk associated with it. Q4 is facility asset utilization, and most people underutilize their data centers. Typical utilization is about 56%. That means that 44% is just sitting there idle. And there's some strategies of how you can deal with that. But this, when people want to talk about green data centers, if they would use these 4 quadrants as a way of articulating how are they saving energy, it would really help the discussion about what constitutes a green data center. One way to think about this is the way to radically improve energy efficiency is you have to break down the silos. And the silos exist between IT and facilities, but they also exist within facilities between the property management function, the facility function, and the project function. Within IT, there are boundaries between the people who do architecture and capacity planning, the people who do evaluations, the people who have business units, who oftentimes are not charged for the true costs of what it takes to provision what it is that they want. So you have a lot of silos, and the problem is that this problem has become so big that the silos must be broken down. To do that, we recommend a czar. Someone they have to be a senior vice president or higher, someone with the objective of cutting energy consumption in half, not a 10% change, in half. A big goal, and depends on the size of the company. But if you can cut energy consumption in half, that means you don't need to build a new data center. It means that there's big OpEx savings, there's big carbon reduction. And the reason that it needs to be a czar is that there's going to be a lot of resistance to this. And so it needs to be somebody with enough authority and enough respect and with enough ability to negotiate to try to bring these functions that previously haven't had to work together for the common interest of the corporation.